Good morning, students. This is SHAFI from Don Bosco PU College, Chitradurga. Welcome back to the maths class of first year PUC. In our previous class, we learned about the definition of a function and also along with their examples of a function, right? And also in our previous class we learned about how to verify the given relation is a function, isn't it? And also we solved so many questions based on to verify whether the given relation is a function or not a function. And also we discussed some note points related to a function, isn't it? In this class we are going to discuss about domain, codomain and range of a function. Already we have been discussed in our previous class in our relations topic. There also we have discussed about domain, codomain and range of a relation. Here we are going to discuss about the domain, codomain and range of a function. How to define domain, codomain and range of a function. Already we know that the domain, codomain and range in a relation topic, isn't it? Here we are going to discuss about the topics domain, codomain and range of a function, how to define these three in a function. Kindly do not confuse. In relation and function we have domain, codomain and range, but at the same time we have a little bit difference to define the domain, codomain and range of a function and also in a relation. You just compare these definitions along with the previous one. You came to know about what is meant by domain, codomain and range of a function or a relation. Okay, let us define. If f from a to b is a function, if f from a to b is a function, if the relation f from a to b is a function, then the set A is called domain, set B is called codomain. Okay, here the set A, here the set A is called domain. The set B is called codomain, okay. If a relation f from a to b is a function, here the set A is called domain, set B is called codomain. What about range? Range is nothing but the set of all the images, in the codomain is called range, of the function. These are the definitions of domain, codomain, range of the function. Okay, you just compare these definitions with the previous definitions. You came to know the difference between these one. Okay, here f from a to b is a function, the set A is called domain, set B is called codomain. Range is nothing but what? The set of all the images in the codomain is called range. Okay, based on this we will take one example. We will consider one example. Okay, here we have a relation. That relation is a function. Let us consider a function f from a to b, Let us consider an example of a function f from a to b. Set A consists of 1, 2, 3. Set B consists of a, b, c, d. Okay, set B consists of a, b, c, d. Now 1 is related to b, 2 is related to a, 3 is related to c. Okay, is this a function? Yes, it is a function. 1 has only one image b, 2 has only one image a, 3 has only one image d. Okay, therefore it is a function. Then what is the domain of this function? What is the domain of this function? Domain, codomain, range. Yes, what is the domain of this function? Domain, I already told you that f from a to b is a function, then the set A is called domain. Set A 1, 2, 3. 1, 2, 3 is a domain. 1, 2, 3 is a domain. Codomain is what? The set B is called codomain. A, B, C, D is the codomain. A, B, C, D is the codomain. Understood? Range is nothing but what? The set of all images in the codomain is called range. The set of all images in the codomain, the set B is called codomain. The set of all the images A, B, D. C is not a image. Okay, A, B, D are the images, right? A, B, D are the images. C is not an image. Understand? A, B, D is the range. A, B, D is the range. Once again, if f from a to b is a function, then the set A is called domain. 1, 2, 3 is the domain. Set B is called codomain. A, B, C, D is the codomain. Range is what? The set of all the images in the set B is called range. A, B, D is the range. Understand? You just write down these definitions in your notebook. Domain, codomain and range. F from a to b is a function, set A is a domain, set B is a codomain, set of all images in the codomain is called range of the function. Okay, here it is a example of finding the domain, range and codomain. And also here we have one note point. I mean, you just kindly note 1, B is the image of 1, A is the image of 2, D is the image of 3. These words you have to know. These words we are using in the second year concept, so that you have to know these kind of words, these kinds of words. A is the image of 2, B is the image of 1, D is the image of 3. A here A is the image of A is the image of 1. Okay, A is the image of 2. Sorry, it is a 2. A is the image of 2. A is the image of 2. B is the image of 1. B is a image of 1. B is a image of 1. Right? It is 2. It is 2. B is the image of 1. D is the image of 3. D is a image of 3. Understand? A is the image of 2. B is the image of 1. D is the image of 3. But C is not an image. Right? Next, what about the reverse one? A is the image of 2. Then 2 is a pre-image of A. A is an image of 2, then 2 is a pre-image of A. Next, A, not A, it is 2. 2 is a pre-image of A. 2 is a pre-image of A. 2 is a pre-image of A. 1 is a pre-image of B, 1 is a pre-image, 1 is a pre-image of B. Okay, next 3 is a pre-image of D, 3 is a pre-image of D, right? It is a domain, codomain, range. A is a image of 2, B is a image of 1, D is a image of 3. At the same time, 1 is a pre-image of B, 2 is a pre-image of A, 3 is a pre-image of D. Understood? Are you understand? Yes. Then kindly note down this example in your notebook. Here we have the question. You just see this question. Let n be the set of all natural numbers and the relation R be defined on n is nothing but natural numbers, such that R equals to, that is a relation, R equals to ordered pair x comma y, such that y equals to 2x, x comma y is belongs to n. Find domain, codomain and range of R. Is this a function? Is this relation is a function? Here we have the question. Here the relation is given in set builder form. Okay, here the relation is given in set builder form. Now, how to find the domain, codomain and range of the relation R? First of all, we have to know about, is this relation is a function or not a function? How to find this relation is a function or not a function? Okay, first of all, we have to verify whether the given relation is a function or not a function. After that, we will find the domain, codomain and range of that relation, right? Let us represent this relation in a roster form. Let us represent this relation in an arrow diagram. Okay, based on that arrow diagram, we will find the domain, codomain and range. You just see, let us take arrow diagrams. It is a relation, R from, it is a relation R from. We know that it is x and it is y. These things I already told you in our previous class. It is x and it is y, right? Here he given that x comma y is belongs to n, isn't it? In the roster, in the set builder form itself, in the question itself, he said that x comma y belongs to n, isn't it? Is nothing but x is a natural number, y is also a natural number, isn't it? Then it is a natural numbers and it is also a natural numbers, x belongs to n, y belongs to n. Then domain is a natural number, codomain is also a natural number. Okay, now natural numbers are what? In the bridge course itself, I already told you that which are the natural numbers. Natural number starts from 1, 2, 3, 4, 5, 6 and so on. So these are the natural numbers. Natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on. Okay, if you want to write, if you want to continue this numbers, you can continue. I don't have that much space to continue the numbers, so that I have written 1 to 6. In the codomain I have written 1 to 12. Now we know that it is these elements are x, these elements are y, right? It is x and it is y. y he already defined in the question itself. Y equals to 2x, y equals to 2x, y equals to 2 times of x, y equals to 2 times of x, right? Once again, we here n with a set of natural numbers and the relation R is defined in set builder form. We have to verify whether this relation is a function or not, and also we have to find domain, codomain and range. X belongs to n, y belongs to n is nothing but both are natural numbers. Natural numbers I have written in the arrow diagram. This set is x, this set is y, isn't it? The elements of the set n is y, y equals to 2 times of x. He already given y equals to 3x. Okay. Now, if x is 1, if x value is 1, then y equals to what? You just to put in place of x 1. Then if x equals to 1, then y equals to what? If x equals to 1, then y equals to what? 2. If x equals to 1, y equals to 2, right? 2 times of x. If x equals to 2, y equals to 4. 2 2s are 4, right? Next, if x equals to 3, 3 2s are 6. 2 into 3. Next, if x equals to 4, 2 into 4 is 8. 2 into 4 is 8. If x equals to 5, 2 into 5 is 10. 2 into 5 is 10. If x equals to 6, then 2 into 6 is 12. 2 into 6 is 12. If x equals to 7, then 2 into 7 is 14. 14. Next, if x equals to 8, then 2 into 8 is 16, right? Like this, we will define this relation. You just observe, is this a relation? Sorry, is this a function? Is this a function? Every element in the domain has one and only one image in the codomain. Therefore, it is a function. 1 has only one image 2, 2 has only one image 4, 3 has only one image 6, 4 has only one image 8, 5 has only one image 10, 6 has only one image 12. Similarly, 7 has only one image 14, 8 has only one image 16, like that. Like that, it will continues. Is this a function? Yes, it is a function. Yes, it is a function. Yes, it is a function. Okay. Yes, it is a function. Now we have to find the domain, codomain and range. How to find the domain, codomain and range? If you want to write this relation in a roster form, you can write, but no need of that. That's why I am not writing this relation in a roster form. Now, domain is what? Domain is what? Codomain is what? Codomain is what? Next, range is what? Range is what? You just observe the arrow diagram. Domain is what? 1, 2, 3, 4, 5, 6, 7, 8. All this set is what? N is nothing but natural numbers. Domain is natural numbers. Domain is what? Natural numbers are 1, 2, 3, 4 and so on. All are natural numbers, isn't it? Natural number starts from 1, 2, 3, 4, 5, 6 and so on. Codomain is what? Codomain is what? Codomain is also natural numbers. Codomain is also natural numbers. Codomain is also natural numbers. That is 1, 2, 3, 4, 5, 6 and so on, right? Range is what? You just observe range 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 and so on. Like that we will get the range. Once again, range is what? The set of all the images in the codomain is called range. The set of all the images 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and so on. Like this we will get. Then that numbers what we call 2, 4, 6, 8, 10, and so on. That numbers what we call even numbers, isn't it? I already told you in the bridge codes itself that numbers we call even numbers, which is a number divisible by 2 is called even numbers. Even natural numbers 2, 4, 6, 8, 10, 12, even natural numbers. Even natural numbers. Okay, even natural numbers. Even natural numbers is what? 2, 4, 6, 8, 10, 12, and so on. All these are the even natural numbers. So hence it is a problem. Kindly note down this problem in your notebook along with this arrow diagram. Okay, I hope you understood. Okay, now one note point is that this note point already we know, range is always a subset of codomain. Range is always a subset of codomain. Okay, this point we already know, and also we verified this condition in our previous classes. That means in relation topic already we have verified this one. Therefore, hence we can say that range is always a subset of codomain. Whatever may be in the relation or in the function, this condition is always true. Range is always a subset of codomain. Okay. Okay, now let us move on to the next definitions. Now let us move on to the next definition. That definition is a real valued function. What is meant by a real valued function? Write down the definition in your notebook. If range is a subset of R. R is nothing but real numbers. R is a real number. Range is a subset of R, that is real numbers. Then it is called real valued function. Real valued function. Okay. If range is a subset of R, range is nothing but what? The set of all images in the codomain is called range. Then it is called range. That range is a subset of R. That range, if we have the real numbers in the range, then it is called, that function is called real valued function. Okay, it is a definition of real valued function. Next one, next definition, real function. Real function. What is meant by real function? These two definitions are very similar. Kindly do not confuse. If range is a subset of R, then we can say that function is a real valued function. Okay, real function is what? If both domain and range is a subset of R, is a subset of R. R is nothing but real numbers. R is nothing but real numbers. Subset of R, then it is called real function. Are you understand? These are the definitions of real valued function and real function. Real function is nothing but if both domain and range is a subset of R, is nothing but real numbers, then it is called real function. If range is only the subset of R, then we can say that real valued function. Okay, if both domain and range is a subset of R, then we can say that it is a real valued function. Are you understand? So these are the two definitions of the real function and the real valued function. Kindly note down this definitions in your notebook. Let us take examples of these two definitions. For example, here we have the function, let f from n to n defined by f of x equals to 2x plus 1. f of x equals to 2x plus 1. Is this a real function or a real valued function? I already told you in the previous examples that f from n to n, here we have the function, we have a function f from n to n, f from n to n is nothing but natural numbers 1, 2, 3, 4, 5, 6 and so on. Next n, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. Okay, it is what? X. It is what? X. It is what? Y. Y is nothing but 2x plus 1. f of x equals to 2x plus 1, isn't it? Now, if x value is 1, you just substitute in place of x along with 1. If x equals to 1, 2 into 1 plus 1, 2 plus 1 is 3. If x equals to 1, then y value is 3, that is f of x is 3. If x equals to 2, then 2 into 2 is 4, 4 plus 1 is 5. Don't be confused. Here we have f of x equals to 2x plus 1, isn't it? If x equals to 1, then f of x equals to what? 2 into 1 plus 1 is what? 3. If x equals to 2, then f of 2 is what? 2 into 2 is 4, 4 plus 1 is 5. If x equals to 3, then f of 3 is what? 2 into 3 is 6, 6 plus 1 is 7, like that. So if x equals to 3, then it is 7, right? If x equals to 4, then f of x is what? If x equals to 4, then f of 4 is what? 2 into 2 is 4, 2 4s are 8, 8 plus 1 is 9. Okay, if x equals to 4, then it is 9. Understand? Like this it will continues. Now, real valued function and real valued function. What we define? If the range is a subset of real numbers, then we can say that it is a real valued function. Real function is what? If both domain and range is a subset of real numbers, then we can say that it is a real function. Here domain is what? Natural numbers. Domain is what? Natural numbers. Okay, domain is natural numbers. Codomain is also natural numbers. Codomain is also natural numbers. What about range? Range is what? 3, 5, 7, 9, 11, like that. So range is what? 3, 5, 7, 9, similarly 11 and so on. Like this we will get range. Now let us define real valued function and real function. Real valued function. Here real valued function. Let us verify it is a real valued function or not. Real valued function is nothing but what? You just see the definition of the real valued function. Range is a subset of R. Range is what? Range is what? Range of this function is what? Range of this function is 3, 5, 7, 9, 11. Therefore, range is this range is a subset of R. R is nothing but what? Real numbers. Okay, R is nothing but real numbers. Range 3, 5, 7, 9, 11, all these are real numbers, right? All these are real numbers. Therefore, range is a subset of R. Therefore, it is a real valued function. Therefore, it is a real valued function. Okay. Similarly, what about real function? Is this a real function? Real function is nothing but what? What is the definition of real function? If both, here we have the definition, if both domain and range is a subset of R, if both domain and range is a subset of R, then we can say that it is a real function. Here we have the domain, here we have the domain natural numbers, here we have the domain natural numbers. Domain is a subset of R, that is what? Real numbers. And range is also a subset of R. R is nothing but real numbers. Natural numbers is also called as real numbers, isn't it? Natural numbers are also real numbers. Therefore, domain is a subset of R. Range is also a subset of R. Therefore, we can say that it is a real function. It is a real function. Okay. It is an example of a real valued function and real function. Kindly note down this example in your notebook. Okay, real valued function. Therefore, hence this example is a real function as well as real valued function. Okay, understand? Okay, dear students, I think you understand the concept of the real valued function, domain, codomain, and range of the function. In the next class, we will discuss about the types of functions. That types of functions are very important for your point of examinations. In the next class, we will discuss about the types of function. It is the class for today. In the next class, we will continue. Thank you.